And now, to provide you with a little more detail on the lab's features and capabilities, Mr. Jim Queen.
Thank you, Bob, and good morning, everybody. I'm the nerdy engineer in the crowd. They don't let us out very often, so when they do, I'm going to provide a few factoids for everybody. You know, this is the official opening of the lab, and it's clearly part of General Motors' efforts to develop energy alternatives and advanced technologies that clearly are going to reduce our dependency on petroleum, improve fuel economy, and reduce emissions. And it's also the latest move in GM's comprehensive battery strategy, which includes ramping up in-house, and I emphasize in-house, responsibility for advanced battery technology and bolstering our portfolio of supplier partners. And these clearly are going to be the keys to sustainable transportation. Now, we're pursuing several energy options to best meet the varied needs of our customers from around the world, from advanced gasoline, diesel, biofuel technology, to electrically assisted vehicles such as hybrids, plug-in hybrids, and ultimately, electrically driven, extended range electric vehicles. Now, of all these options, we believe that electrically driven vehicles offer the best long-term solution for providing sustainable personal transportation. So it's really a privilege for me to spend a few minutes giving you an overview of the new Global Battery Systems Lab, which is one of the most technologically advanced facilities in the world. It's a facility that will accelerate GM's reinvention by bringing research and development of battery cells, modules, and packs in-house. We are committed to being the leader in the electrification of the automobile, and the lab will help us deliver on that promise. Now, our state of the lab spans about 33,000 square feet, which is over 4 times the size of GM's existing lab here at the Warren Tech Center, or the equivalent of 7 basketball courts, and that's a lot of hardwood. Planning actually started in December of 2007. Construction commenced last August, and this facility was partially up and running in January when the pack testing began 9 months ahead of schedule. And this accomplishment is a great example how the new GM is working faster through the exceptional teamwork of our employees and our supplier partners like Roncelli Incorporated, who provided the labor to install the wind generators, A&D Technology Incorporated, who supplied the test automation equipment, Cincinnati Sub-Zero, who installed thermal chambers, Aero Environment, who provided the pack cycling equipment, and Bitrode Corporation, who supplied us with cell and modeling equipment. And I really want to thank all the key suppliers for the role that you played in helping us bring this facility to life ahead of schedule. We couldn't have pulled it off without you, and I want to thank you very much. Our facility then became fully functional in May when our cell and module testing came online. Over half of the lab is dedicated to testing the electrochemical battery cells. This is providing us with a significant increase in our cell testing capability. And then the lab's remaining floor space is committed to evaluating completed battery packs. The lab's maximum power capacity is 6 megawatts, or enough electricity for approximately 1,400 homes. Together, the increased power and capacity of our new lab is allowing us to vastly increase our battery pack testing. Now, the new lab has 160 test stands to analyze the capability of individual batteries, while 42 thermal chambers duplicate extreme real-world environmental conditions, hot and cold temperatures, and extreme humidity. The chamber's environmental control capability also gives us improved correlation and repeatability due to the addition of new humidity-controlled walk-in chambers, airflow benches, and coolant chillers. An additional piece of test equipment includes a thermal shaker table for structural integrity testing. This allows us to physically, electrically, and thermally cycle the pack, simulating real-world driving conditions. This has resulted in a drastic reduction of development time and will significantly increase our speed to market. We've also set aside an area in the lab for battery teardowns in order to perform competitor benchmarking. The new lab also features integrated safety and test automation systems, allowing us to perform standardized and unmanned testing. The automated systems will enable round-the-clock testing in conjunction with our other battery test facilities in Mainz-Gestel, Germany, Honey Falls, New York, and here at the Warren Technical Center. Now, we've also incorporated design of experiments methodology. It's an information gathering exercise which allows us to perform more thorough battery tests in a much shorter period of time. Now, like most GM facilities, our new lab also includes many environmentally friendly features, including a center hallway that features high-efficiency LED lighting and a floor made from recycled tires. In addition, approximately 90% of the electricity used for battery testing can be returned to the local energy grid for use by homeowners and businesses. We're also developing and experimenting with wind turbines placed on the outside of this facility as a renewable energy source to power the batteries being tested inside. Now, in summary, we have come a long way since we first introduced our vision for the electrification of the automobile in the form of the Chevy Volt concept car. We're going to begin production of the Volt late next year, and this facility will go a long way towards getting us there. It's yet another step in the important reinvention of our company and the automobile. I want to thank you very, very much for your time, and now I'd like to turn it back over to Bob Cruz. Bob.